So I introduce myself. I introduce myself. My name is Andrei Nekrassov. I'm working as a research engineer at EDF R&D, mostly on economic and regulation issues related to innovate solution, energy solution like storage or smart grids. So for this reason, I'd like to share with you that I found in my works for several years, for the moment, on smart grids researches. So, just as introduction, when they proposed to me to work on smart grids economics and regulation, I was very excited, and I said, yes, of course, just because of that. You go to the internet and you see that very, very beautiful pictures. So you have the interest to go through, to live in those countries. But, so there are many artists working on it, but not only artists. And from the first moment when you are looking at smart grids, you see that there are a lot of industrial actors, economic actors that are really interested in smart grids, and you ask yourself, why? What is smart grids? So the first question that I think we need to ask ourselves, say, what smart grids exactly are? When I was preparing my presentation, I thought about asking you about what you know about smart grids. If first you heard about smart grids, and what is your understanding of smart grids? But helpfully, Nureddin spoke to you yesterday, and I think now you know more or less what smart grids are. But nevertheless, in my mind, there is no consensual vision, consensual, simple understanding on what smart grids are and what smart grids are not. So, if we are looking about several sources, you see that, for example, the European Technology Platform for Smart Grid provided some definition, very, very formal definition. The sense of I won't read it, but maybe you know already this text. Anyway, you will have the slides and you can read it. But the sense of that we have to leave, I would say, the energy transition, the transition of the power system from the, I would say, centralized and top-down organized structure to decentralized and the system with power flows in both senses. And we need to add the financial flows and services flows in both senses. So we understand that we need to understand and to be sure that it will work. Because if there is problem in this transition, we will have global blackout in the future. So the vision, global vision of smart grid is that smart grid should help us to perform this transition. If we try to go a little bit more in the technical aspect, we can say that there are two infrastructure that should be married in order to produce smart grids. So for the electrical infrastructure, power infrastructure, and information and communication infrastructure. That is the very common slides. It's not my slides that you can find on internet. But I added this part because it's like your iPhone. You have the very nice machine to make calls. This machine can perform a lot of other things, but you will never pay almost 1,000 euros for this machine if there is no application on it. Just to put call, it's not it has no sense to pay this sum. So you need appliances. And the appliances and services is, from my point of view, the third component of the smart grid concept. If we go a little bit more in the technical aspect, you can understand, you can identify several physical infrastructures. So we have some elements to increase the automation of distribution and I put some time to find the picture.
We've seen a lot of it.
But to be serious, when we are speaking about automation of power grids, we can imagine that there is a physical infrastructure where we need to put a lot of things to do it. We need to charge electrical vehicles. That is another infrastructure. And obviously smart infrastructure. The microgrids, I think you have heard about that. It's very, very known topic for the moment. Smart metering, of course. And smart metering, normally we have just boxes for the moment, even in France. And when we're speaking about smart metering, it's about boxes that we're speaking. But the future smart metering, the link in France or advanced metering infrastructure is not boxes. Boxes is just a little part of that. We will speak about the system, including boxes and very important information transmission and analyzing and storing infrastructure. So it will be smart metering infrastructure. Supergrid, I don't speak about that because for me it's not very soon that we will really have affair to that in the long-term perspective. And all infrastructures managing distributed resources, generation, storage, and even demand response need some smartness. So it will certainly be another smart grid infrastructure. So this introduction can answer to the question, what exactly smart grid are? I think it's very important to say that we know we can define smart grids. It's not true when somebody are saying that it's too flow, it's not concrete. Smart grids can represent all and nothing. It's not true. We can as engineer, I can say it, but you will see that even from economic point of view, it's more or less clear and could be defined with precision. So the next question is how smart grids can work. It's just examples. I present 2 examples. I think I will not spend a lot of time because the yesterday presentation of Nuruddin, I know, already addressed this question. Just the example related to the voltage drops, because we have some limitation of voltage drops, and in classical scheme, the regulation of the feeder is that in the end of the feeder we don't not to exceed the limit of voltage drops. But with photovoltaic system we will not the voltage drops, but the voltage over voltage phenomenon. So there are 2 solutions: to reinforce feeder or to introduce the real-time voltage control. That is smart grid function. And that I won't detail that, but anyway, the advantage of smart grid solution is that you don't need to buy and to install new cables and new transformers, maybe. That is very difficult to do economically, but also from the public acceptance point of view. It's not evident to obtain the public acceptance or for reinforcement of power infrastructure now. So there are several difficulties. So smart grid could be helpful in this situation, but smart grids can have also a relatively high cost, and the smart grid solution. The disadvantage it could cost. We don't know for the moment if the technical feasibility is really on the good level. We need to prove it, and we need also to provide the proof of the social feasibility, because in this case, by piloting the demand, we need that the consumer accept to participate in it. So this scheme will be more complex, not only technical, like in the case of the conventional reinforcement. The next example is just the peak demand that is during relatively little time. Is an example from French demand curve. For it's not important the date, just to see that we need to provide power generation assets to ensure the demand in this period. And if you look at forecasts for the evolution of the demand, peak demand in power, in megawatts, not in megawatts hour, you will see that it will increase toward 2030. So this part will increase, so we will need to invest in picking power plants. I'm speaking about the conventional solution, just to guarantee the alimentation during the relatively little time. We know that a smart demand response can bring the reduction of this peak demand during those years. The question is about cost and efficiency of this measure, but anyway, if we arrange to reduce the peak demand in this point, we can help. We can hope to reduce the need of the picking plants. So we can expect to reduce the investment, the future investment in the generation assets. But we can economize, but in the same time, the same type of question appears. We need to prove the efficiency, the social, the technical efficiency, the acceptance of this type of solution, because smart solution will involve a big number of actors. A residential consumer. Well, it's just a very little example. I can provide a lot of examples, but if I try to make some resume of all potential benefit that smart grid can bring, you can produce this type of table. And the most interesting part of this table is arrows that are going in every sense. It means that those infrastructures of smart grid are contributing to very various potential benefits to the power system. For example, we can reduce outages or reduce the non-distributed energy thanks to smart grids. And we can see that different infrastructures can contribute to that. And each infrastructure can contribute to different benefits. And it's not very easy to understand to which extent each infrastructure is contributing to benefits. Anyway, we can we can begin to answer to my first question, why a lot of actors, economic actors, I mean rational actors, are very involved in smart grids. Here you can see that metering operation, energy supply, grid operation, generation, transmission system operation are involved. So you see that big number of actors are objectively concerned by this type of potential benefits. And if I try to make a little summary of this part, we can say that smart grids could be seen from two different points of view. The first is saying that it could represent an economic alternative to existing conventional solution of the power system. Because now in the Europe, the power system is working. There is no problem. And normally the power actors have competition, have resources to deal with difficulties, and even there are some solutions to integrate the renewables to the system. So we can expect that smart grid will bring the reduction of the cost, because that is the cost that is a critical problem now regarding, for example, renewable integration. But there are some new levers that smart grid can bring to us. I mean, without smart grid, we cannot reach the same degree of environmental contribution of every actor, every consumer. It's interesting, but for example, if tomorrow I decide I want to better contribute to the CO2 reduction by modulating my consumption of electricity. But it's very difficult for the moment. In France, we have the signal day and night signals, so I can increase a little bit my consumption by night and reduce my consumption by day, but I cannot follow in real time or near to the real time the real need of the system from the flexibility point of view, and for example what is the CO2 production by the power system in each moment, and try to reduce my consumption when the most pollutant generation assets are activated. For the moment, I cannot do it, but because I have not signal. Smart grid can provide the signal, can bring me this signal. We can imagine some new services to consumers, unimaginable without smart and information technology integration to the power system. And of course, the policymakers have a very strong hoping about job creation and industry development, and some studies are showing that potentially smart grid transition will help the society to create new jobs. Well, now I think I explained a little bit what smart grid are, how it can work, how it can provide benefits, which type of benefits it can provide. But now let's focus on actors that want to access to those benefits. If you take the example of France, all those actors, it's not all French actors involved in smart grids, but it's just some examples to show that not only suppliers or network operators that are involved in smart grid, power smart grids, but you can see the engineering companies. You can see demand response aggregators, it's normal, it's energy services. But brokerage companies or IT companies. So the landscape is very heterogeneous. And to understand how all of those actors are willing to work with smart grids, let's try to make a little analysis of that. So here I present different, I would say, the evolution of the vision of the role of smart grids. by the complexity of the role. Here, I put the different type of actors regarding each type of role of smart grids, and here I try to imagine some business models related to that. So the base vision, as I said, smart grid can facilitate the control, the management, and the optimization of power system. The most concerned actors is the conventional utilities and manufacturers, because they will try to use smart grid to increase equipment performances, to increase potentially the safety of the power system, and to reduce costs. It's a job of those actors to do it. And that is the conventional business model. Those actors, that is their role from the beginning of the integrated power system. But smart grid can be seen also as the way to provoke, to incentive customers to change the behavior, their consumption profile. Now we are consuming when we want to consume without thinking about is it appropriate or not from the ecological or economical or technical point of view. Smart grid can act on it, and there are new energy services providers that are appearing in the landscape. So I call this business model like advanced services to the power system that smart grid integration can facilitate. And in the future, some actors are already thinking about it, is to use smart grid as a vector to integrate the power system in the global services concept. As potentially you can observe the global economic process, more and more services are proposed, suggested by actors. So the idea to integrate all services in the unique package can potentially provide a high added value. So there are actors already that are proposing this type of integrated smart services, not smart grid, but smart services. Could be smart grid, smart waste, smart transport, smart, I don't know, water supply, etc. services. And for example, the concept of sustainable city now is very developed, and several policymakers are ready to spend a lot of money for that. But the way to integrate the power system in it is to use the smart grid concept. Speaking a little bit about the regulation. If we try to classify all of those actors, we can identify the, maybe you can put more groups, but I put it 4 groups for main groups. It's utilities, conventional utilities, industrial actors, I mean manufacturers, and services provider, institutional actors, more or less local and regional authorities, and association. And you can see that the motivation are divergent. There is no convergence in motivation. Each actor tries to take his own part from this play. So we need some referees. It's very important. And referees are institutional actors. National and, in the European case, it's national and European regulators and governments. There are some difficulties because local regional authorities has connection with central authorities. So they can potentially have some lobbying force regarding the referees. But from the other hand, I think all the actors have also their connection to institutional actors. So I think the play is not very simple, but is absolutely needed to make the small grid progress in the good sense. And speaking progressing is just some example of European decision impacting the small grids implementation and development. And the principal message of that there are a lot of work, institutional work on the European level. And for the France, I have the same scheme. You can see it in backup slides, but the message is it's very intensive work now to find the right way for smart grid to progress from the regulatory point of view. So if we try to observe the situation, first we can consider that a lot of actors are very interested in smart grids and very supportive to smart grid implementation, but they are waiting. Yes, they are supportive, but their interest cannot be convergent. And moreover, the feasibility, technical, social, and first of all, economic feasibility are not completely proven. So the situation is a lot of actors are on the start position, are ready to start, to go forward. They are waiting for the signal, for the shot to start. And the public bodies, for the moment, are not completely ready to make this shot because they want to be sure that the small grid implementation will provide a public benefit, not individual but public benefits. For this reason, the public body regarding small grids are requesting very often studies, assessment of small grids, assessment from the technical, from societal, from environmental, and from economic point of view. And another way to find the good answer to those questioning is to create demonstration and experimentation projects. And for this reason that we can observe a very big number of demonstration projects. So as I have not a lot of time, I will provide just some example. For example, in the United States, I think the information is concerning the 2012 or 30. I don't really remember, but it's relatively recent. Almost $8 billion are allowed by American society, invested by American society in smart grid projects, and 40% of this investment are done by public bodies. There are two types of funding programs. It's smart grid investment grant. It's to really invest in smart grid solutions, and smart grid demonstration program to demonstrate the innovative solution. And the same thing, we have 40% of public investment on that. In the Europe, we have 560 smart grid projects in 240. It's a European Commission report. The value of the total cost of those projects is comparable to the American level. Most of them are related to the deployment of smart metering, of course. But demonstrator of all the solution represent, I think, 15%. And in Europe, we have 50% of public funding of those projects. It means that public bodies are very interested in promoting smart grid transition. In America, in Europe, they are following more or less the same way, by different manner maybe, but the same way. They try to help actors to implement smart grids. Another point is that sometimes the smart grid implementation decision is not completely, I would say, economically rational. Because if we take the smart metering deployment in Europe, we can constatate that the main part of decision, and final decision, are taken before, yes?
I can't see the writing. Could you read the green red one?
The green means that the smart metering deployment is going ahead, is decided, and the decision is positive.
It's like stoplights.
Not started, but the decision is more or less positive. The yellow or orange part is that there is not yet decision on smart metering implementation. And the red part is that the analysis are negative. Cost-benefit analysis is negative, or the decision is negative. Well, but if, for example, we take the example of the Italy, when smart metering was deployed already for many years. The decision to deploy it came before the cost-benefit analysis on it. So it was clearly the policy decision. It's not just business decision. So from this point of view, we need to understand that smart grid is a part of the strategic direction, strategic domain of the national and European industries. Regarding economic assessment, two types of questions we need to answer. Is first, is there the cake with smart grids? And for that, we can use cost-benefit analysis or macroeconomic analysis. And if the cake exists, the next question is how to divide it between actors. It's not at all evident. To answer to this question, just an example. In France, we have a very big number of demonstrator projects. 100 projects referenced by the French regulator. So the work is hard. Last year, the French government launched a very big initiative to provide a cost-benefit analysis of smart grids. A big number of actors, major actors of the power system, was put together to do the work, and the result allowed us to first to say if smart grid solutions could be interesting from economic point of view to the France, in the French context in the future, and what is the ranking method to identify the most interesting from this point of view functions and to focus on implementing them at first. And this work will continue. So I continue to justify the message that the smart grid deployment is a policy affair in countries. So I have no real conclusion because the question is open, it's still open. What is the future of smart grids? My constatation is, I think, my feeling is it will be go on. And even we have not all the needed information to start and to begin the course. We will have that in the future. But regarding the revolution, that is the revolution, but the revolution will be performed very slowly because it's not easy to change the technical nature of the power system. So in 20, 30 years, the paradigm of power system will change, but progressively. The stakes, first, we have identified a lot of benefits, but we need to better understand what costs and what risks are associated to them. And the next question is how to provide this type of assessment. We need a consensual methodology. And that is related to the next point, new business models. It's if you try to analyze a little bit more in details how it can work, we can see that smart grids cannot guarantee the spread, I would say, the equitable spread of cost and benefits between involved actors. I mean, it's clear that in smart grid implementation, some actors will ensure mostly the cost, and other actors will access to benefits. And the problem is the actor accessing only to the cost will refuse to participate to that. So if we want smart grids to be implemented, we need to invent a mechanism to share equitably cost and benefits of smart grids. On that, I stop my presentation, and if you have some questions, if we have some time to questions.